finding the rules for sequences. So I'm going to explain this with the following examples. Now, example 1. For each sequence, Roman figure 1, write down the term to term rule. Roman figure 2, work out the position to term rule. So we are given two sequences here. Is that clear? So we are given sequence 3, 6, 9, 12, and B sequence 5, 9, 13, 17. Now let's take sequence A for the first time. So the term to term rule here is add 3 because the numbers in this sequence are increasing by 3 each time. Is that clear? So that's why the term to term rule is what? Add 3. So this is what we are saying. 3 plus 3 is equal to what? 6. 6 plus 3 is equal to what? 9. 9 plus 3 is equal to what? 12. So you can observe that. So the numbers here, they are increasing by 3 each time. So that is why the term to term rule is what? Add. Now, to work out the position to term rule, so let's draw table first. Now, we have position number here. So the numbers there are 1, 2, 3, and 4. Is that okay? So the position number. Now, the terms. You can start by writing the terms on the table here. We have 3, 6, 9, and 12. Now, let's try to write the first 4 multiples of 3. The first 4 multiples of 3, they are 3. 3 times 1, 3. 3 times 2, 6. 3 times 3, 9. 3 times 4. You can observe here that so the sequence matches exactly the multiples of 3. So you can see, so these are the multiples of 3. Then this is the sequence. So they are the same. Is that clear? So from here now you can now generate the position to term rule as what? So you know the position number is what? 1. Still have 2, 3, and 4. Right? So 3 times position number to get each term. Is that okay? So 3 times 1 will give you 3. 3 times 2. So the position number, meaning that multiples of what? 3. The position number will just be changing from 1 to 2 to 3 to 4. Is that clear? So we generate position to term rule. Now let's now look at this B. Now we are having 5, 9, 13, 17. So you observe this one that the numbers here, they are increasing by what? By 4 each time. So 5 plus 4 will give you 9. 9 plus 4 will give you 13. 13 plus 4 will give you what? 17. So the term to term rule here is what? The term to term rule here is add 4. Add what? Add 4. Now, to work out the position to term rule, so let's have this table first. So the position number on this table, we have 1, 2, 3, and 4. Is that clear? Now let's write the sequence on the table. The sequence is what? We have 5, 9, 13, and then 17. Now let's write the first 4 multiples of 4. So 4 times 1, 4. 4 times 2, 8. 4 times 3, 12. 4 times 4, and then 16. Now you can observe here that the term in the sequence is 1 more than multiple of what? 4. So the term in the sequence is 1 more than multiple of what? Multiple of 4. So 5 is 1 more than 4, 9 is 1 more than 8, 13 is 1 more than 12, and 17 is 1 more than 16. Is that clear? So therefore, you cannot write the position to term rule here as 4 times position number, then plus 1. So 4 times position number first time here is 1. So 4 times 1 is what? 4. Then plus 1 will give you 5. Is that clear? So let's take 2 as a sample. If you put 2 here now, 4 times 2 is equal to 8. 8 plus 1 will give you 9, which is what we have here. If you put 3 here, 4 times 3 is equal to what? 12. And 12 plus 1 will give you 13. If you put 4 here, 4 times 4 is equal to 16, then 16 plus 1 is equal to 17. Is that clear? That's why we are having this one, that term is equal to 4 times position number. This is the position number, then plus 1 will give you this sequence. So this is how to generate how to find term to term rule and then position to term rule. Now if this one is clear now, I would like you to do this one on your own.